For pre-lab 3, you're going to have to fill out this particular table down here that we call the accounting table before you can actually answer any of the pre-lab questions. And so what I want to do here is just kind of walk you through the basic structure here and hopefully help you get started on this particular exercise that we have you doing. But if you have questions, you can always come to office hours. You can send me an email or talk with instructors. We're happy to help you out here. Okay, so what is this? So we have this accounting table down here. And what the accounting table does, it's a way we're gonna follow population growth. And so what we have here is a simple model of population growth that we want you to work through. And so the idea here is we're going to start out with what we call our first individual. This is our starting point for this particular model. And this individual, we're going to watch the population grow as this individual gives birth, its offspring gives birth, and we're going to see deaths as we move through time. We'll see that on the right-hand part of the screen here, we have 3 sections here. We have this thing called time and this thing called n sub t. So time here, we can abbreviate that using t, makes sense, right? Time. But then we have these subscripts here, 0, 1, 2, 3, and so on. What the subscripts are telling us is basically what time period we're interested in. By convention, t sub 0 is our starting point. That's where we're going to begin with. T sub 1 is the next time period, whatever that is. It could be the next day, it could be the next month, the next year. Depends on the organism we're looking at, but that's what we're going to be following, and that's how we label those. Then we have this other thing we call n sub t. So when you see capital N, by convention, that's referring to population size, so capital N. Then the T there just represents, okay, what time period we're interested in. And so, for example, here we have T sub 0, that's our starting time period. Then we could have N sub 0, which is the population size at that starting time period. So that's the nomenclature. It gets a little confusing, but that's what we're going to use. If you notice in this table here, we have 3 sections. We have this top section here with a bunch of circles, a middle section here, then a bottom section down here. And we have these different color circles, we have these X's, and we have these arrows all over the place. And so again, I want to walk you through as to actually what this means. So I mentioned that we're going to start with a single individual, so one individual, and then the idea is to watch the population grow from there. So we have 2 rules for this particular model. Our first rule is that each individual will live for 3 time periods. Then at the 4th time period, it dies. And so how are we showing that in these tables here? So every time we have a brand new individual, we colored that white. So every time we're going to show an individual that's born, they're going to be colored white. So that's our starting point. And as they get older, the color changes. They get a little bit darker. So the 2nd time period's alive, it's going to be yellow. The 3rd time period's alive, in this case, it's orange. And then the X here represents death. And so our rule again is the individual lives for 3 time periods, and at the 4th time period, it's dead. And so you'll see a bunch of X's here, but you'll see that every individual here has 3 little circles associated with it. Again, the white circle being when it's born, and then the different colors representing as it ages, and that X representing when it's dead. Our second rule is each time period an individual is alive, it will give birth to 1 individual, and just 1. We're going to keep it simple. But each time period that individual is alive, it's going to give birth. And so even when it's just newly born. So here we have our white individual here, our first individual we're starting with. We can follow its first birth by following these red arrows here. So its first offspring, we follow this first red arrow, it goes to this little white thing right here. Again, the white represents basically a birth, but the arrow is just showing where the first offspring is for our starting individual. Then when the individual is yellow, we can follow the offspring that were given birth at that time period. So, but that arrow is going to drop down here into this second section right here. And the reason we did this is basically its space is limited. We don't have a sheet of paper that's long enough. And so we did it vertically. So hopefully it also makes sense too after I explain it. Okay, so the second time period's alive, it gives birth to 1 individual. That is represented down here by following this arrow. Then the third time period, in this case, it's orange, it's older. It's going to give birth again to another individual. And we represent that by, again, following the arrow way down here. And that's its third offspring. And again, it's white because it's brand new. But then we could track the offspring of the offspring. So think about the grandchildren, the great-grandchildren, the great-great-grandchildren, great-great-great-great-grandchildren, however you want to think about it. So let's go to the first offspring here. So our starting individual gave birth to one individual. That's its first offspring. Then this individual, again, by definition, gives birth to one offspring every time it's alive. Even if it's just brand new, we're just going to go with that, right? So we can track its first offspring by following the arrow way out here to its first offspring. So this would be the grandchild of our starting individual. But then again, our rule is this individual will give birth every time period it's alive. So now it's the yellow age. We could follow its second offspring, in this case, the second offspring here. And then we could track all the offspring of the offspring. And then at the orange age period, we could track its third offspring, in this case, just following this arrow. And then we could track that third offspring as it gets older and as it gives birth. So the distances between one offspring and another doesn't mean anything. It's just trying to shove everything in one table here. Okay, so let's go back here so we can look at the first offspring of our starting individual. We can look at basically what we consider the grandchild now, and then we can look at the offspring of this individual now. So again, the rule is every time it's alive, it'll give birth to one offspring. So this individual's first offspring is here, its second offspring is here, and its third offspring is here, and so on. And we can track that and follow that pattern all the way through. And then same thing here, the second offspring from our original individual, we're just tracking that in this section here. And then all the offspring of the third time period, its third offspring, its third child, however you want to think about it, we're going to track those down here. So first thing you want to do is just work through this, and you can start filling out this section right here. So again, T sub 0 is our time period we're interested in. N sub T is our population size at that time period. At T1, we can go just follow the row here. And at T1, we see there are two individuals. We have our original individual, and then we have its first offspring. So we have two individuals, and then we can just put in 2 at T1 here. Then we go to T2, we can do the same thing. So we can go all the way back here. We see there's an individual here, an individual here, and an individual here. And then we can just put, what was that, 3. We can put a 3 right here and just do that all the way down. Basically, what you're doing is counting how many circles there are. How many circles are there? When you have a death, so there's an X here, that's the death. We don't count that one. So that individual's dead. It's no longer in the population. We're not going to count it. So in this case, we're going to go 1, 2, 3, 4. And that would be, at least for this row here, the number of individuals. But then we want to keep track again of what's happening of the offspring of the second offspring. And so that's down here. So we have the same time periods here. So these time periods represent the same time periods up here. And so at T2 in this case, we have 1. At T3, it's going to be 1, 2. At T4, it's going to be 1, 2, 3, 4, and so on. And then you'll do the same thing down here. And when we get to this table here, it's important to take into account all 3 of these values that you have here. And I'll get to that in a sec. Okay, so go ahead and fill that in. And then we'll go through the counting table. Okay, I'm assuming you did that. Okay, so now let's go through the counting table. So what I want to do is just pay attention to these columns right here. I'm going to ignore this for now. I'm going to start with this region right here. And so we have some other nomenclature we're throwing at you. And nomenclature is just a different way to, a fancy way to say terms, right? And abbreviations and things like that. Okay, so we have our time periods here, T sub 0 all the way to T8 here. So basically the same idea that we have here. We have this thing we call N sub T minus 1. So again, remember N sub T is our time period now. the one we're interested, okay, what's going on now? N sub t minus 1 just refers to the time period before that time period we're interested in. Does that make sense? So it takes a little bit to think about, okay, what we're trying to get at here. But N sub t refers to that time period we're interested in. That could be, I originally said it's now. And so let's think of it that way. What's happening now? Then N sub t means, okay, what happened? What's that population size in the past? So what's our population size today versus what's our population size yesterday? So think of it that way. I think that might help. We have births. I think that's self-explanatory. But you notice there's a plus sign here, right? So we're thinking about populations growth, and we're thinking about trying to understand how large a population will get. Births are going to add to the population. And so in our population models, we put a plus there. But then we have deaths, and you notice deaths is a minus. Deaths take away from the population. And so we're going to use a negative term there because that's going to remove individuals from that population. We add all these things together, we get a population size at that time period we're interested in. Okay, so how do we do this? Well, let's look at T0 here. So our starting time period, this T0 is the same T0 we have here, here, and here. So all the same. At N sub t minus 1, that means the time period before we started this exercise. And so for this model, we're just going to assume there's nothing there. And then this thing magically appeared. So we're not going to worry about what was there previously. And so it's going to be 0. Then we had one birth. We had this one individual that magically just appeared. So we have a birth here. We had no deaths yet. Because again, by definition in this model here, our rule is the individual will live for 3 time periods before he dies. Okay, so we can add all these together. We had nothing to start with, but then all of a sudden this individual appeared. We had no deaths. Our population size now is 1. And so t is 1 at T0. And that makes sense. I go up here, I can count. There's 1 here. At T sub 0 here, there's nothing. T sub 0 here, there's nothing. Okay. Then what I want to do at T1, I'm going to take this value here and move it to T1 right here in this space right here for N sub t minus 1, because now I'm interested at time period 1. But this box here is what's the population size at our previous time period. So I'm going to transfer this 1 value to here. Then by definition, every time period an individual is alive, it's going to give birth to 1 individual. So the birth, we have 1 individual, it's going to give birth to 1 individual here. And so we could go back to our table here and see that, right? At T sub 1, we had our original individual here. That's where this number comes from. It's our original individual. It's yellow now, but that's our original individual. But in its first offspring, it gave birth to 1 individual. We have that individual there now. We have 1 here and 1 here. So we're going to put the 1 here from, because it's yellow here, and then this white, we're going to put here, that's the birth right here. We have no deaths yet. We add these together. 1 plus 1 is 2. And that makes sense. We add the circles, 1 plus 1, and hopefully you got a value of 2 here, right? Then we continue that process. So this 2 goes down to here. At T2, you should have 2 births. So go to T2 here. There's 1 yellow square. And then at T2, we're going to look at this little yellow circle here. So I call that a square. It's a circle. I know my shapes. Okay, that's a circle here. We have 2 circles at T2. And we're going to count this one here. This, again, we put the offspring at the second time period of this individual down here just for space considerations. But we had a birth at T2 here and a birth at T2 here. So there's 2 births, but at T2, there's still no deaths. And you're just going to work through the table as you move down. Notice at T3, we're going to start seeing a death here. At T4, we have some deaths. T5, there's some deaths. And there's going to be some deaths down here at T5. Then at T6, we'll see some deaths down here at T7 and so on. And so you're going to start counting deaths as that population ages. So you want to make sure you include those values in here. Because again, what are we doing? We're adding up. We're adding up individuals to figure out what's that population size at every time period. Okay, what's our population size now, plus how many births are happening, plus how many deaths are happening. That's going to tell us that population size, taking into account all of this. Okay. we've filled in row 6 here for you, so you can check yourself and just to make sure you're on the right track. If you don't get the same numbers here as you're working through this process, go back and see if you missed counting the dots here. But just remember, every individual you have here, you're gonna have the same number of births. Each individual is going to give birth to one individual at every time period. So these two rows basically should be the same number. But then the deaths obviously will vary. And then this number, you'll see it increase as you're adding individuals. Okay, what's all this stuff here? So I got another thing to throw at you here. So we have n sub t plus 1. What does that mean? So n sub t was a population size at a previous time period. N sub t plus 1 means the population size at that future time period. So whatever that is. So in this case here, relative to t0, the future time period is t1. So here, what is the population size at t1 with respect to t0? That's where this 2 comes from. This 2 basically comes from this box right here. So we figured this out, right? We figured this out. We got a value of 2. This 2 is going to go up here. Same idea here. What's going in this box here basically was the population size at t2. That value is going to go here, and so on all the way down. And then we have a little bit of math for you to do right here. And so here we have a calculation, and this is going to be some questions on this in the lab manual, the pre-lab actually, is, okay, taking n sub t plus 1, this value here, and dividing that by the population size at that time period. So in this case here, the population size at t1, that's what this is, the population size at t1, divided by the population size at t0. That's where that 2 comes from. You can do the same thing here. This will be the population size at t2 divided by the population size at t1. And you can do that all the way down here. Okay, so why are we doing this? So this is actually a way to estimate growth rate. So you're learning in lecture ways to estimate growth rate, looking at births, looking at deaths. This is a way to do that as well that you might want to do in the lab that you're going to be doing on here. So you can measure birth rate or growth rates here for a population. There's this other thing called density here. There's a pre-lab question that walks you through how to do this calculation. So go ahead and read that when you get to it. Just fill in this table here. But you notice there's a per meter squared here. And we're talking about density. We're talking about now a physical area these things are in. And so remember in lecture, you learned about density dependence and density independence. What do we mean by density? How many individuals are in a particular area? And so you're going to go through this calculation here, and the lab manual will tell you, okay, what area to use to do this calculation. And hopefully you'll start get a better understanding of what do we mean by density as that population increases. Okay, that's how you go about filling in this table here and working through this exercise. If you have questions, come to office hours or ask us. We want you to be able to work through this. But just think about this. What are we doing here? We're starting with a single individual, and we're watching this population grow relatively quickly over time. And then in the pre-lab itself, you're going to answer some questions as it relates to that to try to help reinforce, the ideas of population growth that you're learning. Okay, hope this helped, and we'll see you if you have questions.